You didn't need a calculator for this one? All right, there are two main ways in math that we measure angles. Two main ways. So what you see on your screen is radians and degrees, right? Since you were taught what an angle is and that it can be measured and some angles are larger than others, since you learned that, you've been using degrees. All right, so today we're going to review. You should have done this in geometry, but maybe not. We'll see. You should today learn what is a radian. All right, so first of all, let me just show you what a radian is. And you don't need to know this, but you might want the background. All right, let's say we took a circle, and then I measured an angle on a circle. And I measured it in degrees. This would be something like, 70 degrees or so. Imagine I'm in the middle of this. I can look and see from there to there. I can compare this point to there. I can get a protractor out, and I can say, hey, that's about 70 degrees, right? From the central location. A different way to measure an angle is by using radians. Right? And radians don't measure using degrees, or they don't measure from the viewpoint of the center. Radians are kind of odd. All right, so if I measure 1 radian, what it is it's equal to whatever the radius is of a circle, and it's equal to the radius as a distance around the arc of a circle. So if I traveled a distance around the circle that's equal to the radius, that is 1 radian. And we abbreviate it just like that. Now, if I asked you, and you were walking on a circle, and I said, hey, can you please walk 70 degrees? You were walking on a circular track. Do you think you could do that very easily? That would be hard to do, right? How could you know whether you're at 60 or 80? It'd be kind of tough to figure out exactly where 70 degrees was. But if I said, hey, can you walk 1 radian? You could do that. For example, let's say the radius of this circle was 100 feet. Do you think you could estimate about, by your walking on a track, what 100 feet was this way? Yeah, you could do that. And so that's what a radian is. It's a distance around the circle that's equal to 1 radius. That's what a radian is. Now, how do we go from a radian to a degree? All right, so here's one thing you need to know. Pi radians is equal to 180 degrees. That's one thing you should write down right now. So pi radians, exactly pi, like the number 3.1415926, blah, blah, blah. Right? That many radians is equal to 180 degrees. And what that means is if I drew a circle and I said, hey, there's this angle, and that angle is from there to there, that's 180. That means this location is pi. Right? 180 degrees rotation is equal to pi radians. All right? So on this assignment, we're going to go back and forth between radians and degrees. We're going to convert. So let's do one of these right now. Convert this angle, which is in radians, change that into degrees. Now, remember what I said. I'm going to do this a little bit differently than what Con might show you in the notes. All right? Remember this. What's pi radians equal to? 180 degrees. So instead of writing 29 times pi over 115, instead of writing that, I'm going to take out the pi, and I'm going to substitute what? 180. And instead of radians, it now becomes degrees. I just swap it out. Right? 180 in for the pi, right there. So somebody help me with that on a calculator. See if you can beat me. I'm going to try to do it in my brain.
think mine's in my car.
12, 60. Dang it. You beat me. Just by a hair. All right, 348 degrees. There we go. And there it is. Let's see if we can go the other direction. Let's see if we can go the other way. So now we have 345 degrees. Let's see if we can change that into radians. Here's what we're going to have to do. When we go from degrees to radians, we want to say this. There are pi radians in how many degrees? 180 degrees. So what we're really doing here is like dimensional analysis, right? You guys remember that from physical science and all that fun stuff, right? So I'm getting rid of degrees. So I set it up this way with degrees on the bottom, and I'm turning it into radians. It says express your answer exactly. So when we do this, don't type in the pi when you have your answer. Let me show you what I'm saying. And even though it says take pi divided by 180, what I'm actually going to do, I'm going to take 345 divided by 180. But I want to write that as an exact fraction. So the problem is if I do it on a calculator like this, it spits out that answer. That's not exact. We want a fraction as an answer. So some of your calculators will reduce these fractions for you. Right? Some of you have to do it in your brain. Let's reduce 345 over 180. They can both be divided by what number right now? 5. Okay, so let's do that. 345 divided by 5. 69. What's 180 divided by 5? 36. Can these be reduced? Yes. Yep. What goes into each of these? 3. That would be 23 over 12. Now, don't forget, that's just dividing by 180, right? We also have this little pi. But do not multiply by the pi button on your calculator. That's not what we're trying to do. We're trying to rewrite it exactly. So our answer is going to be 23 pi over 12. If you saw that little shortcut I did, if you're just using the keyboard, if you just type in pi, it'll change it to the pi there. Or you can click the little button. This is one way you could write it. You could also write it this way with the pi off to the side. It's off to the side, although it kind of looks like it's underneath. Okay, that also works. All right, so that's 2 examples. How we go from degrees to radians, radians to degrees. We did each one of each. All right, so let's try out this assignment now.